The first second of the universe. In the beginning, there was nothing. No space, no time, no matter, no energy, not even emptiness. Because emptiness itself needs space to exist. And then, in a moment we still don't fully understand, the universe began. Not as an explosion in space, but as the sudden expansion of space itself. This was the Big Bang. A singularity, infinitely dense and hot, suddenly began to stretch. Time was born, space was born, energy surged into existence, filling the newborn cosmos with unimaginable heat. In the tiniest fraction of a second, far less than a blink, something extraordinary happened. The universe didn't just expand, it inflated. During this brief but astonishing phase known as cosmic inflation, space grew exponentially, doubling again and again and again, faster than the speed of light. Quantum fluctuations, tiny jitters in energy at the smallest possible scales, were stretched across the universe. These ripples became the blueprint for everything: galaxies, stars, and even the vast cosmic voids. Then, just as suddenly as it began, inflation ended. The immense energy that had powered inflation was released into space, heating it up in a process known as reheating. The universe became a blazing furnace, filled with a dense soup of pure energy. Out of this energy, particles began to form. The fundamental building blocks of matter appeared: quarks, the seeds of protons and neutrons, leptons like electrons and neutrinos, and countless photons, particles of light, though the universe was still far too hot for light to travel freely. But for every particle, there appeared an opposite, an antiparticle. Matter met antimatter, and they annihilated each other in flashes of pure energy. Almost everything was destroyed, but somehow, for reasons we still don't fully understand, a tiny imbalance remained. For every billion pairs of matter and antimatter, there was one extra particle of matter. It wasn't much, but it was enough. Enough to form every star, every planet, every galaxy, and every living thing that would ever exist. At this early stage, all forces of nature may have been unified, a single, symmetrical interaction. But as the universe expanded and cooled, symmetry broke. Gravity separated first. Then came the strong nuclear force, binding quarks together. Later, the electroweak force split into two familiar forces: electromagnetism, which governs light, electricity, and magnetism, and the weak nuclear force, responsible for radioactive decay. From one came four, and as the forces took shape, so did matter itself. Quarks joined together to form protons and neutrons. These were the first atomic nuclei. Though atoms could not yet exist, the universe was still too hot, too dense, too chaotic. It was a universe of plasma, where particles collided constantly, light was trapped, and the forces of nature battled for control. And yet, in this apparent chaos, order was slowly emerging. By the end of the first second, the universe had cooled to about 10 billion degrees, still hotter than the core of any star, but cool enough for a new era to begin. Neutrinos, ghost-like particles that rarely interact with matter, decoupled and began their endless journey through space. Their imprint, a cosmic neutrino background, still lingers, though we have yet to detect it directly. Protons and neutrons began to combine into simple nuclei, hydrogen and helium. This process, called nucleosynthesis, would continue for minutes to come, laying the foundation for all future chemistry. And though no atoms had yet formed, though no stars yet burned, though the universe was still a glowing fog of particles, everything was in place. The forces were defined, the matter had survived, the balance between energy, mass, and expansion was struck. The story of the universe, of galaxies, of planets, of life had begun. And it had all happened in just 1 second, the first second of the universe. If you enjoyed this journey into the birth of the universe, like, subscribe, and explore more cosmic mysteries with us.